Today we're going to talk about standard form of a quadratic function. Yesterday we said anytime we write a function in the form of y equals ax squared plus bx plus c, where the a value is not 0, we're said that this is the standard form of a quadratic function. That's standard form. We can find information about a quadratic function by looking at the coefficients a, b, and c. The graph of standard form is called a parabola. And we saw yesterday that when the a value is positive, the parabola will open upward. And when the a value is negative, the parabola will open downward. We know the axis of symmetry is the line x equals opposite b divided by 2 times a. And this is the x-coordinate of the vertex as well. X equals opposite b divided by 2a. The y-coordinate of the vertex is found by substituting that x value, opposite b over 2a, into the equation, and it will give us the y value. And then finally, we know the y-intercept in standard form is the c number. When we let x be 0, then c will be the point where the parabola crosses the y-axis. If you use a calculator to find the features in the quadratic below, we'll look at the table, and I'm going to give values from -4 up to +2. And I see that my y values are -16, -1, 8, 11, 8, -1, and -16. And if you look carefully, you can see how the parabola begins to repeat itself. So what do we know about this middle value? That's going to be our vertex. -1, 11. And we know that x equals -1 is the axis of symmetry. And the parabola opens downward, so we have a maximum value at 11. And we know that the range goes from -infinity up to +11. It includes +11. We also know that the y-intercept is our c value, so we could add that to our knowledge. Our c value is 8. So we know where the vertex is. This was our vertex. And we know that this was our c value here. And we know that we had an upside down parabola because the a value was negative. Notice here that we have a detailed set of instructions, 7 steps, for how to graph a parabola that's in standard form. So we're going to use those steps in example 2. We want to graph x squared minus 4x plus 1. So first we're going to identify a, b, and c. So we know a is 1, b is -4, and c is +1. And we can decide that the shape of the graph is going to open upwards because the a value is positive. And if we do opposite b, our b value is -4, divided by 2 times a, then we're going to get 4 divided by 2. So x equals 2 is the coordinate of our vertex, and at x equals 2, that's the magic line that divides our graph in half. We also know that the vertex, that's the x-coordinate, so the y-coordinate of the vertex is substituting 2 back into the original equation, and solving y is -3. So our vertex is 2, -3. Then we also know that our c value is 1, so 0, 1 is on our graph. And if we reflect that point, it's 2 units away from the axis of symmetry. So if we go 2 units to the right, then we can reflect that point. And 4, 1 is also a point on our parabola. And then we have enough to sketch our parabola. So we have a nice smooth curve like such, using those 7 steps. Example 3. We're going to do the same thing and record our information. So we know x coordinate for the vertex is opposite b divided by 2a. So the x coordinate is opposite b, which is positive 2. So negative 2 divided by 2 times a, which is negative 2. This is a, this is b, this is c. So we have 1/2 is our x-coordinate, and then we're going to substitute negative 2 times 1/2 squared plus 2 times 1/2 minus 5. So negative 2 times 1/4 is negative 1/2 plus 1 minus 5. So our y-coordinate is negative 9/2. So the vertex is at 1/2, negative 9/2. So if we come over here at x equals 1/2, this is our axis of symmetry, and negative 9/2 is at negative 4.5. So 1/2, negative 4.5. We know our y-intercept is 0, negative 5. That's our c value. And our axis of symmetry is x equals 1/2. I'm going to clean this up a little bit. And then at 0, negative 5. So if we reflect that point, we're at 1, negative 5, and 0, negative 5. They're both 1/2 of a unit away from the axis of symmetry. And we have a nice smooth curve. Actually, if you substitute 1 or 2 into the equation, you find that you get negative 9. So you can also reflect that point. Next, we're going to move on to the algebraic approach. We want to find vertex form for the next 2 equations. So our goal, remember vertex form from yesterday, our goal is to get our equation in the form of y equals a times x minus h quantity squared plus k. So first things first, I know that my a number is 2, and next we need to know what our vertex is. So looking for the vertex, we're going to do x is the opposite of b divided by 2 times a. So our x coordinate is going to be 2, which is going to turn out to be our h value. And our y coordinate, we'll plug that back in. The f of 2 is 2 times 2 squared, that's 4, minus 8 times 2, that's 16, minus 3. So 8 minus 16 minus 3 would be negative 11. So the k value is the y coordinate of our vertex. So we have hk is positive 2, negative 11. This is our vertex. And then finally, we've met our goal. So our goal was to write this equation in standard form as vertex form. So y equals a, which was 2, times x minus h, which is 2, quantity squared, plus k, and k was negative 11. You may want to turn off the video and try example 5 on your own, then come back to check your work against mine. I know my a value is negative 1, and x is the opposite of b over 2a, so our x value is 2, which is the h coordinate, and then substituting the f of 2 into negative 2 squared plus 4 times 2 minus 5 gives us negative 4 plus 8 minus 5. So the f of 2 is negative 1, and this is our k value. So to finish that up, if a is negative 1, and h is positive 2, and k is negative 1, then our equation is negative 1 times x minus 2 quantity squared minus 1, vertex form. For example 6, we want a model for the performance of a stock is given as p equals negative 3d squared plus 50d. D represents the days of trading, and p is the price per share. We want to know what is the maximum price per share of the stock. So this sounds to me like we need to find the vertex, and the y-coordinate is going to be our maximum. So we need the vertex. This is our goal. We need the vertex, y-coordinate, because our parabola is opening downward, and then we would have the maximum if we knew what the y-coordinate was. So giving that a shot, we need x is the opposite of b divided by 2 times a. So this is 50 divided by 6, or 25 thirds. So evaluating the parabola at 25 thirds, we've got negative 3 times 25 thirds squared plus 50 times 25 thirds. Now I'm going to go to my calculator and evaluate that. $208.33. Therefore, the maximum price per share is about $208.33. The maximum price per share is about $208.33. Okay, then we have one more example. In this final example, we want to interpret the quadratic graph. So the New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with this function given here. X and Y are measured in feet. We want to know approximately how high above the river is the bridge, and we want to know how long is the bridge. So first thing we want to do is find our vertex. So x is the opposite of b divided by 2a. So we're going to use our equation. X is opposite b over 2a, and b is 0.847 divided by 2 times our a value, which was negative 0.000498. So using our calculator, we're going to get about 850. And this is in feet now. So y is evaluating into our equation 0.000498 times 850 squared plus 0.847 times our x value, which is 850. So being careful on your calculator, my result is 360. So putting that answer into words, we know the height above the supports. So let's say this, the height above the supports is the y-coordinate of the vertex, which is about 360 feet. feet. And we know the height above the water, is 360 feet plus, let's go back and look at the picture. We've got this 360 feet plus 516 feet. So that's about 876 feet. And then the length of the bridge is double the x-coordinate of the vertex, since we have to go, if this goes 850 feet, if we go 850 feet this way, we have to go 850 feet that way. So we're going to double that, and we're going to write that down here. So the length of the bridge is double the x-coordinate of the vertex, which was 850 plus 850. So the length of the bridge is 1,700 feet. So a picture is worth 1,000 words. That ends lesson 2.